In this video, I'm going to show you how to algebraically solve for exact values of a trig function. So in this question, we are only looking in the interval from 0 to 2 pi, meaning we really only care about the values that are going to pop up on the unit circle. And we are given the equation 4 times sine squared of theta minus 2 equals 0. Solving this trig ratio, or this trig function, is exactly like we solved everything else in algebra. You want to isolate the variable. In this case, our variable is theta. So we have to start peeling everything away from that theta by doing the reverse of PEMDAS. What is the thing that's happening last? Because that's the first thing you have to peel away. So we have a minus 2 here, so we're going to add 2 to both sides. That's going to leave us with 4 sine squared of theta equals 2. The next thing that we need to do is divide by 4 because we are trying to get that theta alone. So now we've got sine squared of theta equals, well, 2 divided by 4 is just 1/2. Now we're going to square root. Remember that every single time you square root, you get the plus and the minus. Well, the square root of 1 is just 1, and the square root of 2 has to stay in that root. But we always rationalize. We don't let square roots live in our denominator. So I'm going to multiply by root 2 over root 2, and I am allowed to do that because root 2 over root 2 is just 1. And when I do that, I end up getting plus and minus 1 times root 2 is root 2. Root 2 times root 2 is 2. So I am looking for where on the unit circle does sine of theta equal positive or negative root 2 over 2. I guess that should be a theta equals because we're solving for theta. So we've got our unit circle down here in the left-hand corner, and our sine values are always y. If you have a hard time with that, it's alphabetical. Cosine comes first, x comes first, sine comes second, y comes second. So we're looking at our y values. The first time I see root 2 over 2 is pi over 4. So this is going to be pi over 4. The next time I see root 2 over 2 in the y spot is 3 pi over 4. The next time I see it in the y spot is 5 pi over 4. And I'm looking at the radians because right here it says that our interval is 0 to 2 pi. If our interval was 0 to 360, then we'd look at the degrees. The next time I see root 2 over 2 is going to be 11 pi over 6. And for this particular question, not 11 pi over 6, 7 pi over 4. For this particular question, we want all the positives and the negatives. There's our answer. What we just solved for were all of the values that make this true. All of the values that I could plug in that would give me a 0 as my outcome. Now, if you have a really hard time kind of working through this, you can use Desmos to help you out. What I did here was I plugged in the equation. 4 times sine squared of x equals 2, or minus 2. And I know I want this to equal 0. If you put equal 0, it's going to put straight lines at all of the values. The problem is that Desmos then won't tell you what those values are. So you want to keep it like that, and then you're able to click at all these critical values. Now, we only care about up until 2 pi. I don't want to go beyond 2 pi because the interval says go to 2 pi. So any value that this equals 0 before 2 pi is our answer. So pi over 4, which we got. 3 pi over 4, 5 pi over 4, and 7 pi over 4. So essentially, those values are what make this statement true.